Today's lesson's on 6.3, which is on logarithms. Now, logarithms are something you haven't worked with before, so this is a new concept. Our objectives are the student will be able to define and evaluate logarithms, use inverse properties of logarithmic and exponential functions. So we have to be able to go back and forth between logarithmic functions and exponential functions. So, our core concept. Definition of a logarithmic function with base b. Let b and y be positive real numbers with b not equal to 1. The logarithm of y with base b is denoted by this. It's read log base b of y equals x. And again, IFF is just an abbreviation for if and only if. This means it works both ways. So if I have a logarithm written this way, I can transfer it to exponential notation this way. Log base b of y equals x, if and only if b of x equals y. And log base b of y equals x is read, which I've been saying, log base b of y is how this is read. Okay? Now, so we're going to be converting between logarithmic form and exponential form. The key is logarithms are used to solve when we have a variable in the exponent, like 3.76 to the x power equals 4.32. We have no way in your toolbox that you have on math right now to do this, where the variable is in the exponent, to solve this except by guess and check. And so logarithms can be used to solve these type of problems. If the variable is not in the exponent, then we can use exponential form to solve it. So we have to be able to go back and forth between the two of these. So if it's logarithmic form, then log base b of y equals x, exponential form b of x equals y. B is the base, okay? X is the exponent. Here's our exponent here, here's our exponent in logarithmic form. And then y is the answer. So our answer here goes in the logarithm part over here. And we should be able then to convert these back and forth fairly easily to use whatever method we need to solve the problem. So, the first thing we're going to ask you to do is to rewrite the logarithm in exponential form. So it's pretty easy if we remember our rules. This is our base, 2, this is our exponent, 4, and our answer, 16. So 4 to the 0 power equals 1. 12 to the first power equals 12. And 1/4 to the negative 1 power equals 4. If we check these, we know that 2 to the 4th is 16. Anything to the 0 power is 1. Anything to the first power is itself. And remember, a negative power flips it over, so it becomes 4 over 1, which is 4. And then you're going to be asked to transfer them from exponential form into logarithmic form. So now it just becomes log. Now remember, this is a subscript. If we go back over here, this is a subscript. It's in lowercase down below here. So you want to make sure you write it that way. So our base is 5. The answer goes next, and our exponent goes over here. Remember, 5 squared is 25. So this would be log base 10. Our answer, 0.1, equals our exponent, negative 1. So log base 8 of 4 equals 2/3. And finally, the last one, log base 6 of 1 over 216 is equal to negative 3. Alright, so it's a pretty easy conversion as long as when we do these, we remember that we want to go base here, the exponent's over here, and our answer goes out there, or vice versa, depending on which way you are going. So, we have some special rules of logarithms. Log base b of y equals x is b to the x equals y. That's the one we just went through, the conversion back and forth. Log b of 1 is always equal to 0, and the reason for that, remember, base, exponent, anything to the 0 power is 1. And log base of the same number. If the base here is the same thing here, it's always 1, and the reason for that, again, if you think exponential, b to the first is equal to itself, and so b to the 1 equals b. And so those are three rules that we can use when we're simplifying logarithms. So now I'd like you to try, or actually we'll go through all this example. Evaluate each logarithm. So we want to know what this equals. So if we just evaluate it, well, remember that means it's equal to something over here. So if we think exponentially, it's 4 to the x equals 64. So again, we're going to do these without using logarithms right now, but just to convert it to exponential form. So we have to ask ourselves, what to the 4 to what power gives me 64? Well, 4 squared is 16, and 16 times 4 is 64. So in this case, my x would equal 3. So this would simplify to give me 3. This one, again, we just say, well, that's x. So 5 to the x equals, well, 0.2. Now, how are we going to do that? Well, 0.2 is the same as 2/10, and 2/10 goes to 1/5. Well, remember, what exponent can we use to change 5 over x to 1/5, and that would be a negative exponent flips it. So in this case, our x would be -1, and so this log 5 of 0.2 would be -1, because we got to flip it and got smaller. So if we do this one, it's 1/5 to the x equals 125. Well, again, we have a fraction, right? So if we square this, we would get 1/25. That doesn't help us. But if we think, oh, I need to get that 5 flipped over, so we have to use a negative power. So 5 to what power gives me 125 would be 3, and so that would mean our x would have to equal -3 in this case. Because a -3 power would go 1/5, it would flip it to 5, and it would be 5 to the 3rd power, which is 125. And the same thing on this last one, 36 to the x power equals 6. So now we have to think a little bit here. We got to change 36 into 6. With what exponent does that? Well, the square root of 36 is 6, and what power is that? Remember, that would be 36 to the 1/2 power would give me 6, and so our answer is 1/2. So you also have to consider radicals on this and just write it as a fraction, because 1/2 is the square root. Some other rules. This is a continuation of our special rules for logarithms. Common logarithms are base 10. Okay? It's called the common logarithm because it's used most often. And your calculators will do that. So log base 10 of x, because it's used a lot, we just don't put a base there. So anytime you have a logarithm written and there is no base written here, so no subscript number, then it's base 10. And if we go to the calculator, and this would be in your functions. If we go to our functions, and this would be our logarithm. So it just says log, and the reason for that is that's base 10. So anytime when you're working and it's base 10, you can do it on the calculator and find your answers. So if we go back to the notes, so common log is base 10, so it's just log without any subscript number. That would be base 10. And then another one that's commonly used is natural logarithm, which is base e. So log base e of x, which they'll write as ln x. My guess is for natural log, and so they do it ln. And again, that's on the graphing calculator. If I go to Desmos, you can see there's an ln, which is the same as log base e. And And so you can use the calculator for base 10 and for base e. So if we look at these and they ask you to evaluate each logarithm, log base, or log, this would be log base 10 of 8, we just go to the calculator and we type in log 8 and it tells us it's 0.903. Again, they'll probably tell you what to round off to, whether if it's to the nearest hundredth, it would be 0.9, if it's nearest thousandth, it'd be 0.903. And then the other one, which was ln, 0.3, so we just go back to the Desmos, and we just go back to our functions, and now we do ln, and it was 0.3, and it tells us it's negative 1.20. Again, depending on where they have you round, if it's nearest hundredth, it'd be negative 1.2. If it's nearest thousandth, it'd be negative 1.203. But it will tell you on that what to round off to. So, or 204, if we rounded that off. So again, those are really easy. Base 10 and base e, we just do it on the calculator. So, what I'd like you now to do is to try numbers MP 2 through 12, the evens, and I've got them up here. So, I want you to try these and see if you can do them, kind of reviews what we just went over. So pause the video, try these, make sure you're okay on these. Then come back and check and see how you did. So again, on this, I just want you to change it to exponential form. So my base is 7, my exponent's 1, my answer is 7. My base is 1/2. You have to put parentheses around this because it affects the whole 1/2. My exponent's negative 5, my answer is 32. Now we want to write these in logarithmic form. So this would be log base 50 of 1 equals 0. And this would be log base 256 of 2 equals 1/8. And then lastly, they ask you to do these on the calculator, if necessary. On some of these, like this, we haven't talked about how to do log base 27 on the calculator, so we're going to do this by just converting it. 27 to the x equals 3. So there's no power. We can't change this to what we need it to be, but what can we do to get to 3? And that would be the cube root of 27, which remember is 27 to the 1/3 power. So you should have gotten on this that would simplify to 1/3. And another one we would do on the calculator, so ln 0.75, ln 0.75, and we get negative 2.876, so I'm going to round that up to negative 0.288. Yeah, 3 places. Negative 0.0288. And that would round off. So hopefully that part's pretty easy for you. The converting, and then this will be the hardest part because you have to do it by thinking about it on what you get. The other part's just put in the calculator. So inverse properties. So we talked about inverses on 5-6, and that's why we put that before 6-3. Logarithmic functions and exponential functions, okay? Logarithmic functions and exponential functions are inverse functions, so they cancel each other out. So that leads to some other special cases. If our base here is the same as what we're taking the logarithm of, then our answer is whatever that exponent is. Okay? So if I have log 12 to the x plus 3, my answer is that exponent, x plus 3. Also, if we have a logarithm in the exponent, and the base here is the same as the base here, then again, those are inverse operations. They will cancel each other out, and we will just get x. Or if you have 7, then logarithms in the exponent, then we would just get 2x, because these exponents and logarithms, if the bases are the same, cancel each other out. So they ask us to simplify these. 10 log of 4. Now remember, there is no base here. But if there's no base, it's always considered to be a 10. And so these cancel each other out, and it's just 4. Now when you have something like this isn't the same. But we could convert it. That 25 can be written as 5 squared to the x. Power to a power we multiply. So that's log 5 to the 2x. And so they now are the same, and so they cancel each other out. It's whatever that exponent is, so just be 2x. So they're going to ask you to find the inverses. So again, we can just switch the x and the y and solve for y. So this would be y equals 6 to the x. So I'm going to switch this and go x equals 6 to the y. Now, since the variable is in the exponent, we're going to now use logarithms to do this. So this would be log, remember this is our base, of the answer equals the exponent. So remember, base, exponent, answer. So I put it in that way. On this one, again, we're going to switch the x and the y. Now we're in logarithms, so we're going to switch it to exponential form. So here's where you have to be careful. Remember, ln is base e, and so this would be e. This would be our exponent. E to the x equals the answer. Or there's our answer over here, y plus 3. Subtract 3, so e to the x minus 3 would equal our inverse. Again, these should be g of x for the inverse function. And so you can see, to switch the x and the y, if it's in exponential form, you convert it to logarithmic form. If it's in logarithmic form, we convert it to exponential form to get the inverse. So, I'd like you now to try 13 through 18 in the monitoring progress problems. And so go ahead, pause the video, try these, and then come back and look and see how you did. So on this one, this is where we have the logarithm and the exponent. So because this is base 8, since those are the same, they would cancel each other out, and we just get x. Here, we have the base here, the same as the base here. So again, those are inverses, they cancel each other out. So you should have gotten negative 3x. A little bit more difficult. We need to convert that 64 into base 2. And so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and so that would be to the 6th power. So 2 to the 6x. So now these are the same, so it cancels out. So it's 6x. And this is ln. Well, this is e. Remember, ln is base e, so those are the same and they cancel out, and so you should have gotten 20. So not a lot of work to show on these, but it takes a little bit of understanding. Especially when you get into things like this, where you have to convert it, or remembering that ln is base e, or if it's base 10, it says log, those cancel each other out. And then the last two, the more difficult. To find the inverse, so we should switch the x and the y, and now change it to logarithmic form. So it's log, my base is 4, my answer is x, equals y, or g of x for the inverse. And then this one, change it, again, we're going to change the x and the y. Convert it to exponential form, so ln, our base is e, our exponent is x, our answer is y minus 5, and then move the 5 over, so e to the x plus 5 equals y is what you should have gotten. And then your assignment is page, I guess I should have put the page up here. The page is, let's see this. .314. Sorry about that. So page 314, 5 to 51, the odds, skip number 25. So again, we'll be doing that in class. Hopefully this works out.